Okay, next example is we'll show that y equals 2x cubed is an odd function. Now, as soon as you see odd function, it's a good idea to use a different color and put something, the formula underneath, so you know what you're about to do. So if I put minus x into here, I should have something like this in the end. Okay, so let's do that. That was just my dog barking. F minus x, which will be 2 minus x cubed. Okay, so that's 2 times minus x cubed, isn't it? Because what does that mean? Here is minus x times minus x times minus x will give you minus x cubed. Okay, that we can write it like this. And what's this one? If you think about, that's the same as this, isn't it? F of x. So I can say minus f of x, because y is f of x is the same. Okay, so therefore y equals 2x cubed is an odd function. Okay, good. Next one, we're doing another sketch graph here. Okay, so let's see, put f of x equals x brackets x plus 3 x minus 2. So that's what we have to sketch. Now what's x-intercept when y equals 0? That will give us the x-intercept, the roots, isn't it? X equals what? 0 minus 3, 2. Yeah, so that's for this one and this one and this one. So, and also this is what? Positive, isn't it? It's a positive. So when we do the positive here, our graph will go up, wouldn't it? So it will look like this. So we know, and then if had to cut through, there's a 3 of them, it'll be minus 3 here, 0 here, and 2 here. Okay, so we got some ideas of what it looked like, really. So let's sketch this one. So I'm going to go roughly. Again, I'm doing roughly, you doing in details, okay, using ruler, pencil if you need to, all these things. So I'm going to go, it's going through 0, and it's going to 2, and it's going to the negative 3. So these are my x-intercept, okay, and I have to make this look like that. All right, so roughly I'm going to go like that. I mean, I don't have to worry about y-intercept here because it doesn't hit anywhere in the y-axis. I'm going to push up a little bit so it looks a bit, yep, better. So that's my rough sketch of this cubic function. Okay, now we have to describe part 2 of these. Is it describe the shape of the graph and then state its domain and range. So let's have a look. I'm going to describe this verbally, and you probably need to write this down. The graph increases to maximum turning point. Now that's my maximum turning point, guys. It's because it's got up all the way up to here, and then it changing. That's what we call turning point here. Okay, it's a maximum turning point because there's no other maximum point here. That's a minimum point down there. Okay, so a maximum turning point, and then decrease because it's going up, increasing, and then it's decreasing. So decrease to a minimum turning point. There's a 2 turning point there, turning point, and that's a turning point. One is a maximum, one is minimum. Okay, and then it's increase again. So that's my description. So the graph increases to a maximum turning point, a maximum, not the, a maximum point, turning point, and then it decreases to a minimum turning point, okay, and then it increases. So now domain, what is our domain? Again, it can be anything, isn't it? So interval notation, and again range will be the same, okay, all real x values or real y values for the domain and range. Okay, so that's what it is, and we're about to sketch another one in the next video.